This lesson is on synthetic division, and we're going to look at synthetic division as an alternate method to dividing polynomials. In the previous lesson, you would have learned about long division, but in this lesson, we're going to learn that synthetic is an efficient way to divide a polynomial by a binomial if the binomial is of this form, x minus b. So before I teach you how to do the synthetic division, you have to make sure that before you attempt any division, whether long division or synthetic division, that you've met these two criteria. Number one, the terms must be arranged in descending order of degree in both the divisor and the dividend. And number two, if you're missing any terms, 0 must be used as the coefficient of any of the missing powers of the variable in both the divisor and the dividend. So let's start with part 1, synthetic division when the binomial is of the form x minus b. So the binomial in this section is always going to be degree 1. Notice the exponent on that x is 1, and the coefficient of that x is also 1. That is the best scenario for synthetic division. So if your divisor is degree 1 and its leading coefficient is 1, synthetic division is a very quick alternative to doing long division. So let me show you how to do the synthetic division in this scenario. So we want to divide this 3x cubed minus 5x squared minus 7x minus 1 by x minus 3. You know how to do that using long division, but how can we do a shortcut called synthetic division? Well, you need to start by setting yourself up a table. And in the table, you're going to put in this spot right here, the 0 of the divisor. So what makes x minus 3 be 0 would be the number 3. So that goes there. That's the 0 of the divisor. Across the top here, we are going to write the coefficients of the dividend, making sure that if you were missing any powers of x, you would put a coefficient of 0. But we have a degree 3, 2, 1, and 0, so we have all degrees represented. So I write their coefficients across the top, also making sure they're in the correct order, right? Make sure your dividend is in decreasing order of degree, 3, 2, 1, 0. After we've set this up, what we're going to do is just follow an algorithm that is going to find us the quotient. I'm going to put a couple operator signs. I'm going to put a multiplication sign down here and a plus sign here. Those signs are going to help me remember what operations to do. Now, synthetic division always starts off the same way. You always bring down the first term in the dividend. So bring this 3 down and write it down here in the quotient. Now what we do is the 0 of the divisor, 3, times this 3 that's in the quotient. 3 times 3 is 9. We write it beneath the next term here in the dividend. Now we add the terms in this column. Negative 5 plus 9 is 4. Then we do 3 times 4 and we get 12. Do negative 7 plus 12, we get 5. Do 3 times 5, we get 15. And negative 1 plus 15 is 14. That's the synthetic division. We've done the division. Now we just have to accurately interpret the answer. So these numbers tell us about the quotient and the remainder. The last number is always going to be the remainder. So this last number, I'm going to write an R beneath it because this is the remainder. And then as I move left through these numbers, it's going to tell me the coefficient of each term in the quotient, increasing order of degree. So 5 would be the constant term because that would be the coefficient of the x to the 0. 4 would be the coefficient of x to the 1, and 3 would be the coefficient of x squared. And if there was another number, that would be the coefficient of x cubed, and so on. So we can write our answer now that we have our quotient. Our quotient is 3x squared plus 4x plus 5 with the remainder of 14. So we can write our answer in two forms, remember, either quotient form or using the multiplication statement that could be used to check the division. So let's write our answer both ways. So in quotient form, we always have the division equals our quotient, which we got 3x squared plus 4x plus 5, and then we add the remainder over the divisor. That's quotient form. Or we can write the multiplication statement, which is where we break up the dividend into a product of the divisor and the quotient, and then add the remainder. So both formats, they're just different ways of expressing the answer we found. But the key thing I want you to notice is that these coefficients, 3, 4, and 5, we got from here, 3, 4, 5 in the synthetic division, and the remainder of 14 here as well. So let's try a couple more examples of synthetic division where the divisor is the form x minus b, right? It's a degree 1 divisor with a coefficient of 1. So synthetic division is best when that criteria is met. Before I do this synthetic division, Notice that the dividend has a degree 4, 3, 1, and 0. It doesn't have a degree 2 term. So when I set up the synthetic division, I have to make sure I put in a placeholder for 0. So you can think of that dividend as an x to the 4 minus 2x cubed plus 0x squared plus 13x minus 6. Notice that it's in decreasing order of degree, and all degrees are represented, 4, 3, 2, 1, and 0. Now let's set up our division table. So in the top left, I always put the 0 of the divisor. So what makes x plus 2 be 0 would be the number negative 2. Across the top, I'm always going to write the coefficients of the dividend, making sure that I have the dividend in the proper order with 0 in for any placeholders. So 1, negative 2, 0, 13, and negative 6. Don't forget to put in that placeholder of 0. And now we'll run the algorithm. I'll put my operator symbols here just to remind you of what operations I'm doing. And now I'll run the algorithm. Bring the first term down, 1. Negative 2 times 1 is negative 2. And then add the numbers in the column. Negative 2 plus negative 2 is negative 4. Negative 2 times negative 4 is 8. 0 plus 8 is 8. Negative 2 times 8 is negative 16. And 13 plus negative 16 is negative 3. Negative 2 times negative 3 is 6. Negative 6 plus 6, 0. And let's remember what these numbers represent. The number on the right is always the remainder. So hey, there is no remainder. That means x plus 2 divides evenly into this degree 4 polynomial. And then these numbers are the coefficients of the terms in the quotient. So we always go from right to left. It goes in increasing order of degree. So this would be our x to the 0 coefficient. This would be our x to the 1 coefficient, our x squared coefficient, and our x cubed coefficient. And we can write our answer in two ways. I'm actually just going to write this answer using the multiplication statement. For the next one, I'll do quotient form. This one, I'm going to do the multiplication statement. So the dividend, this x to the 4 function, is equal to a product of the divisor, x plus 2, times the quotient, x cubed minus 4x squared plus 8x minus 3, plus a remainder of 0. So notice we were able to get this into factored form because there's no remainder here. So basically what we just did is we factored this x to the 4 function. It factors into those two factors. So we figured out that both the divisor and the quotient are factors of the dividend. Part B, last one where the divisor is degree 1 with a leading coefficient of 1. So let's set up our table to do the division. So let me start by writing the 0 of the divisor in the top left, and then the coefficients of the dividend across the top here. I should also check, make sure the dividend is in proper order. It's degree 3, 2, 1, 0, so it's in descending order of degree. Great, and all degrees are represented, so I can just put the coefficients across the top here. 2, negative 5, 8, and 4. I'm going to put my operator symbols, so I'm going to put my multiply sign here, my addition sign here, and now I'm going to run the algorithm. Bring the 2 down, do 3 times 2, get 6. Do negative 5 plus 6, I get 1. 3 times 1 is 3. 8 plus 3 is 11. 3 times 11 is 33. 4 plus 33, 37. And then let's write down what each of these numbers represents. Remember, the last number is always your remainder. And then these are the coefficients of the terms in your quotient. This is the coefficient of the constant term. This is the coefficient of x to the 1, and this is the coefficient of x squared. Let's write this answer in quotient form. Since the last time we did multiplication statement, this time let's do quotient form. So what division did we do? We did 2x cubed minus 5x squared plus 8x plus 4 divided by x minus 3. And what we got was a quotient of 2x squared plus x plus 11 plus a remainder of 37, which has to be divided by the divisor of x minus 3. That's quotient form. Part 2 is synthetic division when the binomial is of the form ax minus b, where a isn't going to be 1 anymore. So our leading coefficient is no longer going to be 1. And notice in this example, it's going to be 2. Now, synthetic division only works when the divisor is degree 1, which it still is. But it also assumes that the coefficient is 1. And in this case, it's not. But there is still a way to do synthetic division when the divisor is of this form. What we can do is we can common factor out that 2 from the divisor and then do 2 separate divisions. If I common factored out the 2 from the divisor, this is what I would have, right? Put the 2 out front and then divide the 2x and the 3 by 2, and I would get this product. And what I can do is I can divide this dividend by 2x plus 3 by doing 2 separate divisions. I can divide it by this first, which is degree 1 with a leading coefficient of 1, which is what synthetic division assumes. So I can do that. I can divide it by this. But then after you do that division, you also have to divide it by the 2, because we want to divide it by this whole thing. We'll just have to do it in 2 steps. By this first, and then by the 2 that was common factored out. Let me show you how that works. We'll start by dividing by x plus 3 over 2. So the 0 of that would be negative 3 over 2. So we would write negative 3 over 2 top left, and the coefficients of the dividend across the top. The dividend has degree 3, 2, 1, and 0. Those are in proper order, no missing terms. So I can write the coefficients 6, 5, negative 16, negative 15 here. I'll put my operator symbols. And then I'll go ahead and do the synthetic division. So bring the 6 down, and now multiply that 6 by negative 3 over 2. That'd be negative 18 over 2, which is negative 9. 5 plus negative 9 is negative 4. Negative 3 over 2 times negative 4, that'd be 12 over 2, which is 6. Negative 16 plus 6 is negative 10. Multiply that negative 10 by negative 3 over 2, that'd be 30 over 2, which is 15. And then add negative 15 plus 15, 0. After running that division, remember, all we've done so far technically is divide by this, the x plus 3 over 2. But we want to divide by this whole thing, right? We want to divide by 2x plus 3, which is equal to that whole product. So we've only divided by this. We now also have to divide by 2. So I need to take these numbers, but actually not the remainder. Never divide the remainder after. The remainder is always what you get after that first division. I need to take these 3 numbers and now divide by the 2. So I'm going to write divide by 2. And I'm going to divide each of those numbers by 2, and I get 3, negative 2, negative 5. Those are the coefficients of my x to the 0, my x to the 1, and my x squared. Notice I didn't divide the remainder by 2 as well. I mean, 0 divided by 2, it would have stayed 0, but if it was something other than 0, we would have left it. We wouldn't have divided that by 2 as well. Let me write the multiplication statement for this one. The multiplication statement would be the original dividend, so 6x cubed plus 5x squared minus 16x minus 15 would equal the divisor, so 2x plus 3, times the quotient, 3x squared minus 2x minus 5, plus the remainder of 0. So there we go, there's the multiplication statement. Let's do the same question, but using long division, what we learned in the previous lesson. And then you can decide for yourself what you think is easier to do. I think long division would probably be easier for this one because we don't have to remember those special rules like common factoring out the coefficient and then dividing by both of these things. I think it might just be easier for this one to just do long division. Let me set it up. Okay, let's run the long division. So remember the steps we learned in the previous lesson. First term dividend divided by first term divisor, so 6x cubed divided by 2x would be 3x squared. I'll line it up with its like term. Multiply 3x squared by the whole divisor, and I would get 6x cubed plus 9x squared. Line up the like terms, and subtract. The 6x cubes cancel, and 5x squared minus 9x squared is negative 4x squared. Bring down the next term and repeat the process. Negative 4x squared divided by 2x is negative 2x. Multiply the negative 2x by the divisor, and we get negative 4x squared minus 6x. Subtract like terms, the negative 4x squareds cancel, and negative 16x minus negative 6x is negative 10x. Bring down the negative 15 and repeat the process one more time. Negative 10x divided by 2x is negative 5. Negative 5 times 2x plus 3 would give me negative 10x minus 15. Notice those are the exact same thing. When I subtract them, I get a remainder of 0. So see that we got the same answer? Look back at our synthetic. The coefficients of our quotient here are 3, negative 2, negative 5, and at synthetic, 3, negative 2, negative 5. So we can get the answer either way. It would be totally up to you if our divisor is of this format, where the divisor is degree 1, with the leading coefficient not 1, it would be up to you which of these two methods you do. Example 2 just says find each quotient using an appropriate strategy. It doesn't tell you whether to do synthetic or long division. So as we go through these questions, we'll establish what's the most appropriate strategy based on what the divisor looks like. In part A, the divisor is degree 1 with a leading coefficient of 1. That's perfect scenario for synthetic division. So we will do synthetic division for this. So we'll set up our table. The 0 of the divisor goes here, and the coefficients of the dividend go across the top. 1, negative 4, 2, 3. And was I missing any terms? Nope, degree 3, 2, 1, 0. All are represented in the proper order. So there we go. Now let me put my operator symbols, multiply, plus, and I will do the algorithm for synthetic division. Bring the 1 down. 3 times 1 is 3. Negative 4 plus 3 is negative 1. 3 times negative 1 is negative 3. 2 plus negative 3 is negative 1. 3 times negative 1 is negative 3. 3 plus negative 3 is 0. So I have my remainder, my x to the 0, my x to the 1, and my x squared terms. And I'll write this in multiplication statement form again. That's the one we're going to be using most often, so I'm just going to default to that for the rest of this lesson. So I've got x cubed minus 4x squared plus 2x plus 3 equals, it's a product of the divisor, x minus 3, and its quotient, x squared minus x minus 1, plus the remainder, but we don't have one. So once again, we got this dividend into factored form. Part B. Now this one, the divisor is still degree 1, so technically we are allowed to use synthetic division still, as long as we common factored out that 2. So for this one, you could do it either way, but I think long division would be easier. So I'm going to do this by long division. So I'm going to write my divisor outside of my division table, and then underneath my table, I'm going to write my dividend. I have degree 4, 3, 2, 1, 0, so all terms are represented, so I'll write them all here. And now I'll do the division. 12x to the 4 divided by 2x, give me 6x cubed. Multiply 6x cubed by the divisor, and I would get 12x to the 4 plus 6x cubed. Now we'll do our subtracting. Negative 56 minus 6 is negative 62, x cubed, plus 59x squared, once I bring that next term down. And now repeat the process. Negative 62x cubed divided by 2x would be negative 31x squared. Multiply that negative 31x squared by the 2x plus 1 divisor. That would give me negative 62x cubed minus 31x squared. Subtract the terms, and I would get, so 59x squared minus negative 31x squared, that'd be 90x squared. Bring down the next term. 90x squared divided by 2x would be 45x. Multiply that 45x by 2x plus 1. Get 90x squared plus 45x. Subtract, and I would get negative 36x. Bring down the negative 18 and do the process one last time. Negative 36x divided by 2x is negative 18. Multiply that negative 18 by the divisor, and I would get negative 36x minus 18. And once again, my remainder is 0. That's not always going to happen. That's just what seems to be happening a lot with these questions. So I'll write the multiplication statement. So in the multiplication statement, I write the original dividend equals a product of the divisor and the quotient plus the remainder, but our remainder is 0. So once again, that's in factored form. Like I said, we could have done synthetic for this. So if you're interested in what that looks like, let me just really quickly show you what the synthetic would have looked like for this, and you can see that we would have got the same answer. Okay, there's the synthetic division. Notice we got the correct coefficients of our quotient, 6x cubed minus 31x squared plus 45x minus 18. Notice that matches this exactly. And notice we also got the correct remainder of 0. And one thing to point out again, if you decide to do synthetic division for a divisor of this format where the leading coefficient is not 1, make sure you remember, do not divide the remainder by whatever you common factored out. The remainder stays the same. It just so happens both times we've done it, we've got 0, so it wouldn't have mattered either way. But make sure you do not divide the remainder by what you common factor out from the binomial at the beginning. Only divide the coefficients of the quotient. Part C. This is actually the first time our divisor is not degree 1. Our divisor is degree 2. If the divisor is not degree 1, you are not allowed to use synthetic division. So for this one, there's no choice. We have to do long division. So we'll set up our long division and put the dividend underneath the table, making sure I have the terms in the proper order and make sure I'm not missing any terms. So I've got degree 4, degree 3, degree 1, degree 0. I'm missing a degree 2 term. So in its place, I'm going to make sure I put a 0x squared. And now that it's set up, we can do the long division. So x to the 4 divided by x squared, that would be x squared. Multiply that x squared by the entire divisor. So I'd get x to the 4 plus 2x cubed plus x squared. And then we subtract all like terms. The x to the 4s are gone. Negative 2x cubed minus 2x cubed is negative 4x cubed. And 0x squared minus x squared is negative 1x squared. We bring down the next term, and we repeat the process. Negative 4x cubed divided by x squared would be negative 4x. Multiply that negative 4x by the entire divisor. That would give me negative 4x cubed minus 8x squared minus 4x. Subtract all the like terms. Negative 4x cubes cancel. Negative x squared minus negative 8x squared, that would be 7x squared. And 5x minus negative 4x, that's positive 9x. Bring down the last term and repeat the process for the last time. 7x squared divided by x squared is 7. Multiply that 7 by the entire divisor, and I would get 7x squared plus 14x plus 7. Subtract the like terms. The 7x squareds cancel. 9x minus 14x is negative 5x. And 3 minus 7 is negative 4. This is our remainder. And once again, I'm going to write my final answer using the multiplication statement. So the original dividend, x to the 4 minus 2x cubed plus 5x plus 3 equals a product of the divisor and the quotient plus the remainder. So plus negative 5x minus 4. I could simplify that just by adding both terms. So it would just look like this. Part D, another time the divisor is not degree 1, is degree 2. So once again, we have to do long division. Synthetic division is not an option. So let's set up our long division table. The dividend has all of the degree terms represented, 4, 3, 2, 1, and 0. So I don't need any placeholders. And now I can start doing the dividing. X to the 4 divided by x squared is x squared. Multiply that x squared by the entire divisor. So x squared times x squared is x to the 4. And x squared times 2 is 2x squared. Notice I made sure to line it up with its like term in the dividend. Be very careful with that. So x to the 4 minus x to the 4 is 0. That's gone. Negative x cubed, I'm subtracting nothing from that, so it's still here. Don't lose that negative x cubed. And negative x squared minus 2x squared is negative 3x squared. And I'll bring down the 2x, and I'll repeat the process again. So negative x cubed divided by x squared is negative x. Multiply that negative x by the divisor, and I get negative x cubed minus 2x, making sure I line it up with its like term. And then subtract like terms. The negative x cubes are gone. Negative 3x squared, I'm taking away nothing from it, so it's still there. And if it helps, you could have written here like a plus 0x squared, if that helps you, but you don't have to. And 2x minus negative 2x is 4x. Bring down the 1, and we have one more round of division to do. Negative 3x squared divided by x squared is negative 3. Multiply that negative 3 by the whole divisor. I get negative 3x squared minus 6. Do the subtracting of like terms. The 4x will still be there because we're not subtracting anything from it. And 1 minus negative 6 is 7. This is our remainder. So our final answer, I could write in the multiplication statement form, my dividend equals a product of the divisor times the quotient plus the remainder. And when I'm adding a polynomial, I don't technically need those brackets. So I could just write plus 4x plus 7. All right, that's it for the synthetic division lesson. Hopefully you now know the scenarios where you're allowed to use synthetic division, and you feel comfortable using it as an alternative to polynomial division. Make sure you try out the practice questions, and that's it.